Growing up, I was curious about plants, and that curiosity is what led me to study plant science. And currently, I'm the team lead for maize breeding at the West Africa Center for Crop Improvement, where I'm using innovative genetic technologies to develop crop varieties that are resilient to biotic and abiotic stresses, to contribute to sustainable agriculture and food security. When it comes to Africa, we are dealing with two issues: the availability of food and then the nutrition content of the food. There is a term called hidden hunger. People are eating, but you're not getting the right nutrients. So then it leads to a lot of deficiency in children and pregnant women, which increases their susceptibility to diseases. We see children develop a lot of deficiency-related diseases, which affects how they develop well. So when we are developing crops, biofortification is important. Whilst you are increasing the yield, you have to make sure that we have nutrients available in the food so that they don't need to rely on supplements. It is important that we also solve the problem of making crop production cheap for farmers. For maize, for instance, fertilizer is one of the biggest costs to the production. When too much agrochemical, that is fertilizer and pesticide, is used, it ends up in our water bodies or in our foods. And when we eat this, it brings a lot of challenges in diseases like cancer, respiratory diseases. Also, using too much fertilizer harms the soil. It disturbs the soil ecosystem by killing some of the important beneficial microbes in the soil. And it also reduces the availability of nutrients to the plants. My research that I'm currently doing is to use soil microbes as an alternative natural biofertilizer. Science has shown that we have good microbes in the soil like avascular mycorrhizal fungi. And what that does is it forms a symbiotic relationship with the roots of the plant. So when it attaches to the roots of the plant is able to take up more nutrients better from the soil compared to when the microbe is not there. So it presents a natural solution for us to use as a means of reducing the fertilizer. And we have also found out that when the microbes or the AMF attaches to the roots of the soil, some nutrients that are not easily available to the plants, like zinc, becomes more available. So it means that the nutrients in the crop will increase. So as a way of making our foods more nutritious. So our research is trying to use the soil microbes as a natural way of improving crops, reducing the effects of pesticide or diseases on the crop, and as well as making it more nutritious. On this journey, I have had to face several challenges, including how to balance family life with career, but I've overcome it by trying to balance my life out and also having a strong support system, like my husband that is always there to support me, and also my children. On the career itself, funding, especially when you are in Africa as a young scientist, it's not easy to come by. But I've had mentors that have supported me and encouraged me and put me in places of opportunities that have led to me excelling on the career. I'm thankful to them.